All right, so now we're going to talk about linear functions. So we've talked about linear functions before, but now we're going to talk about them away from Chapter 5 and more in the sense of seeing them as tables or mappings, etc. Group of ordered pairs. So a linear function is a function that has a constant rate of change, and its graph is a straight line. So that was what our Chapter 5 was when we talked about proportional relationships, and then we actually had a section about linear functions, and we talked about graphing using y equals mx plus b. That was more on just slope and y-intercept. Now we're going to be talking about different points and deciding whether a relation is a linear function. And so that's the difference between Chapter 5 linear function and Chapter 7 linear function. But we brought up slope, and so that's something we need to review and talk about. So slope is the ratio between vertical change and horizontal change. And so we wrote it m equals the difference of y over the difference of x, or another way we did y minus y over x minus x. So that's review, slope, rise over run, difference of y over the difference of x. We're going to refer to it in this chapter as rate of change. And so rate of change is equal to slope. They are the same thing. Your slope is your rate of change. Your rate of change is your slope. There will be times that I will refer to rate of change as ROC. So if you see rock, that's what it is, rate of change. But your rate of change is your slope. So let's consider the following ordered pairs. We have 2, 1, 5, 3, 8, 5, and 11, 7. And so the first thing we're going to do is just graph those points. So each of these is just going to go by 1, so I'm just going to label my every other, just so that's 1, 2, 3, 4, 5, whoops. I said 4 and then wrote 3, 4, 6. Alright, so then I'm just going to graph these. So at 2, we are at 1. So there's a point there. At 5, we were at 3, so 1, 2, 3. Of course it doesn't. 8, we were at 5, so 3, 4, 5. And 11 slightly off, so we're going to say it's right here on the edge. So if this is 6, then this one's 7. And not that that's straight, because it's not. So here's my line. Yes, I drew it off camera just because you didn't need to wait as long as it took me to draw that. So because it's a straight line, or in other words, I could think of the vertical line test from section 1, and it would pass the vertical line test. And so because this passes the vertical line test, this is a function. And part of that is for every x value, there is exactly one y value. So that's the whole reason why the vertical line test. So for every x value, there's exactly one y value. Now, I know this is linear and it's not when I give my dot, because it's a straight line. And the other reason I would know is because I can find a rate of change. I can find a slope. So rate of change. And so I would find that. In this case, the easiest is to count. So I go up 2 and write 3. And if I check again, not that these are straight lines, but it's up 2 and write 3. And once again, up 2 and close to write 3, just because that one was off anyway. And so my rate of change, or my slope, is 2 over 3, my rise over my run. And because that is constant, it's a linear equation. So let's move on to our first example. Graph each set of ordered pairs to determine if it represents a linear function. If it does, find the rate of change. Excuse me. Now, because our numbers go up higher than they did last time, each box here is going to be worth 2. So 2, 4, 6, 8, 10. You get the gist. All the way up to 20. And then we're going to do each of our x values as 1. Now we got to keep that in mind when we go to count our slope later. Alright, so I know that when I'm at 1, I am at 5, which is halfway between 4 and 6. And 2 is at 7, so that's halfway between 6 and 8. And 3 is at 9. Give me a point. There we go. 4 is at 11, so halfway between 10 and 12, and 5 is at 13. And so again, I can draw, oh, okay, close enough for me. I don't have the ability to put a straight edge down. I can draw a line through, so the first question we gotta ask is this a function? And the answer to that is yes. We have one input or each input. I don't know why we put one input. Each input exactly one output. So that makes this a function. And then from there, we know that it is linear because the fact that and it's a straight line. So that it's easy to know linear because you can look at it and see a line when you're looking at a graph. Now, because it is a linear function, then we can find our rate of change, which I'm going to refer to as ROC. And so I can take any of these 2 points, or I can count. And so this would be 1, this would be 2. So we'd go up 2 and over 1, and up 2 and over 1. So I know that my rate of change is 2 over 1, which equals 2. Again, the other way, I have a whole list of points. I can do 7 minus 5 over 2 minus 1 and get the fact that we have 2 over 1, which equals 2. And I can do that with any 2 points in that list. I just have to pick 2 of them. But my rate of change is 2. And so that is the end of example 1. Well, the first part of example 1. So here's the second part. Again, we do the same thing. We can do this one by ones. So 1 and 1. So we're going to have a point at 0, 0, a point at 1, 1, a point at 2, so 2, 3, 4, and a point at 3, 9. So this is 4, 5, 6, 7, 8, 9. Now, when I look at this one, I can't draw a straight line through those. This is a curve. And so, because we can't connect with a straight line, it's not linear. Now, that does not make it a function. It is still a function because each of our x values only has one y value. It's just not a linear function. We'll put a linear function. But again, it's a function, just not linear because it doesn't create a straight line. So that's the difference. We can be a function without being a linear function. A linear function means that we can draw a line through our points and connect all points on that line. And so that is it for our first video for 7.3. In our next, we'll talk about using tables to determine whether we have a linear function.